A small change in damper position means a big change in airflow. So a VFD varies the frequency of the electricity going to a motor. So what does that mean? It's kind of like a transmission for the combustion air blower on the boiler. Normally, if you don't have a VFD, if you have like a linkage control system, or you just don't have a VFD and you have a parallel positioning or a fully metered system, it doesn't matter. You don't have control over the fan's speed typically. In years past, that used to be somewhat done with like steam drives on blowers and things of that nature. So that you might see that in like a power plant or something, but your typical package boiler is going to be a fixed speed fan. And so we vary airflow to the burner with dampers. Dampers either on the inlet and or outlet of the blower. And what that means is, even when I'm only using, say, 15% of the total airflow, right? If I'm at turn down at low fire, that fan is still spinning full speed. And so that damper is choking back all of that flow. And that can be a problem for a number of reasons. One of them is that fan is still has the same amount of, it's not using exactly the same amount of electricity, right? It is using less because we're holding it back. But because it's spinning full speed, we're not achieving a lot of savings on that fan. But also those dampers now are pretty close to closed. And so at that point, a small change in damper position means a big change in airflow. And so we get pretty poor control of our fuel-air ratio at the bottom end of that combustion curve when that fan is spinning full speed. So if we can slow that fan down, it does a number of things. Number one, by slowing that fan down, it's making less pressure. So we allow those dampers to get into a better controllable range, and we have finer tuned control of the fuel-air ratio at the bottom end of the combustion curve. Number two, because that fan's going much slower, we reduce the noise in that boiler room a lot. And that can be really nice for operators. Number three, when we slow the fan down, we achieve savings through what's called the fan affinity laws. So fan affinity, AFFINITY. And you can find YouTube videos on pump or fan affinity. Centrifugal pumps and centrifugal fans kind of have this same law. And basically what it means, what it says is, if I run a fan at half speed, then I'm making half the pressure and half the flow. And so I use 1/8 of the power. And so by slowing the fan down when I go to the bottom end of the firing curve, I can have a significant electrical savings. Huge amounts. Now, will it actually be 1/8? Not necessarily, but it could easily be half or a quarter of the electrical usage at the low end of the firing curve. So if you have a large boiler that often runs below high fire, say below 75% firing rate is normal, then you absolutely want to evaluate putting a VFD into that system, because you'll get better control. We can tighten up your O2%, we can tighten up your combustion curve and save some money there, but also you're going to have major electrical savings. And then the last thing that's pretty commonly known about VFDs is that a VFD will reduce or completely eliminate what's called power factor. And I'm no expert on power factor. Again, there's going to be other videos on that. But power factor says that the sine wave of the electricity going to a motor, the voltage and the amperage get out of phase. And when they get out of phase at a large facility that has lots and lots of motors or lots and lots of inductive loads, then now that power is inefficient for other users on the grid. And so the power company is going to charge you a penalty typically if you have lots of those motors. You're going to pay a power factor surcharge. As you put these big motors onto VFDs, you're going to achieve electrical savings, but you're also going to achieve power factor savings. And you're going to have better control and find some fuel savings. So, as well as, like I said, reducing that noise. So it's a really good deal. So I would say anytime we're running a parallel positioning system, which is going to be, maybe 200 horsepower, boiler horsepower and larger, anytime we're doing that, we really should be also including a VFD, because they've gotten to the point in the last several years that they're significantly more reliable and a lot more affordable than they used to be. So get a VFD on that combustion blower. It'll save you lots of money and lots of headaches.